The diagram shows an arc of a circle. The width of the arc is 8 centimeters and its height is 2 centimeters. Find the radius of the circle from which the arc is taken. Find the length of the arc. So we're going to let r centimeters be the length of the radius. So if we actually draw onto our original diagram, so this was the arc given. So here I have the arc drawn again. And I've connected either end with a straight line. And I've drawn in the radius of the arc. So here's the radius, and it's labelled as r. And I've also drawn a line straight down through the middle. So r centimeters is the length of the radius. So there's our radius there. From the right angle triangle shown, let's see, we have a right angle triangle. There's our right angle there. So when we are involved with right angle triangles, there are two formulas that we can use. One is Pythagoras Theorem and the other is SOHCAHTOA. So I'm going to use Pythagoras Theorem to help me find the unknown sides. So Pythagoras Theorem is c squared equals a squared plus b squared. So I'm going to label my triangle. So the distance from here to here is going to be 4 centimeters, because remember the entire distance across is 8. So that was given in the question. And this line here has cut my shape in half. So from here to here is 4, because the full distance is 8. And then if this section here is labelled as r, the radius, then this is also going to be r, because that's also a radius. And we know that this distance from here to here is 2, because that was also given in the question. So then this distance from here to here is going to be r minus the 2. So this distance here is going to be r minus 2. So now we have our right angle triangle labelled. So we have r, 4, and r minus 2. So we're going to label it A, B, and C. So C being the longest side, or the hypotenuse of the right angle triangle, and then the other two sides being labelled as A and B. Doesn't matter which way they're labelled. So again, Pythagoras' theorem is c squared equals a squared plus b squared. We swap the c for r. Going to swap the a for r minus 2, and swap the b for 4. So we have r squared equals r minus 2 squared plus 4 squared. R minus 2 squared will give me r squared minus 4r plus 4, and 4 squared is 16. So the r squareds will cancel out on either side. I can bring the minus 4r over the equal sign, it becomes plus 4r, and 4 plus 16 is 20. And 20 divided by 4 is 5, so the radius is 5. So now that we have the radius, we found the radius of the circle. Now we need to find the length of the arc, so we need to find this distance here. So I've drawn the diagram out again over here, and I've labelled this angle here as alpha. We can label it x, it doesn't matter what you label it. And I'm using this right angle triangle again. So I now know that the radius is 5, so I've labelled r equals 5. This is still a distance of 4, and this is still r minus 2. So since it's 5 minus 2, this is now 3. So then what I'm going to do is label my triangle H, A, and O. So H being the hypotenuse, A being the adjacent, and O being the opposite. And I'm going to use the formula SOHCAHTOA. So I'm going to label this as H, the hypotenuse. Since this is the angle that we're looking for, then the side opposite the angle is going to be labelled as the O. So 4 is O, and then the other side will be the A. So I can use any of the formulas SOHCAHTOA because I have the H, A, and O, but I'm going to go with SO. So SO stands for sine of x equals opposite over hypotenuse, or in this case it's going to be sine of alpha. So I'm going to swap the O for 4, and the h for 5. So since I don't know the angle, I have to use the inverse function, so sine minus 1. I get this on my calculator by pressing shift and then sine. So get sine to the power minus 1, a bracket will open, press the fraction button, put 4 over 5, close the bracket, press equals, and I get 55.13 degrees. So angle alpha is 53.13 degrees, so this angle here. So twice that is going to be 106.26 degrees. So this full angle here, two of them together, because they're obviously both the same, is going to be 106.26 degrees. So to get the length of the arc, it's going to be 2 pi r multiplied by 106.26 degrees divided by 360. So I'm swapping pi for 3.14. The radius I know was 5. I got that from over here. And that's all multiplied by 106.26 divided by 360. Putting all that into the calculator, and I get 9.27 centimeters. So the length of that arc is 9.27 centimeters. Part B. The cross section of a piece of corrugated plastic used for roofing consists of a series of circular arcs, each 8 centimeters wide and 2 centimeters high. A sheet of plastic is 1.6 meters wide. If the sheet could be flattened, how wide would it then be? So from part 1, we got the length of the arc to be 9.27 centimeters. So this distance is 9.27 centimeters. So in the sheet of corrugated plastic, the number of arcs is going to be 160 divided by 8, which is going to be 20. So we've got 160 because we were told that the sheet of plastic is 1.6 meters wide and 1.6 meters is 160 centimeters. And we know that each of the arcs is 8 centimeters wide. So it's going to be 160 divided by 8, which is 20. It's going to be 20 arcs. So the width of the flattened sheet will be 20, because there's 20 arcs, times 9.27 centimeters, because that's the length of one of the arcs, which is 185.4 centimeters. And to change it back into meters, 185.4 divided by 100 is 1.854 meters. So if the sheet could be flattened, how wide would it then be? The sheet would be 1.854 meters.